Imagine a student who performs mathematical operations like a magician, flawlessly executing complex equations on a final exam. But the second that test is over, they shove their textbook into the trash. The traditional educational system is built entirely around testing cognitive variables, verifying that the student acquired specific knowledge and skills. Yet there is an old educational adage: we measure what we treasure. If you look at standard assessment practices, schools rarely, if ever, systematically measure student attitudes or interests. This ignores a central axiom of human psychology. This flowchart illustrates a simple reality: a student's current affective status predicts their future behavior. If a student learns how to compose an outstanding essay, but internalizes the belief that they are a rotten writer, they will actively avoid writing the moment they are no longer forced to do so. Cognitive ability without a positive emotional disposition is entirely inert. If we ignore the affective realm, we have no way to gauge the long-term viability of the skills we teach. Most educators readily concede that student motivation is critical. The gap between that belief and actual classroom practice comes down to logistics. Traditional psychometric tools are incredibly heavy. A standard Likert inventory often requires 10 to 20 targeted questions just to measure a single variable, like a student's interest in reading. Deploying these massive surveys in a typical classroom drains instructional time. The result is rapid teacher burnout and severe student survey fatigue. To bypass this logistical bottleneck, educators use a specific architectural solution: the multi-focus affective inventory. To see how this tool extracts reliable psychological data without consuming hours of class time, we have to pull apart its design piece by piece. This document is an assessment blueprint designed for 4th through 6th graders. Its primary design principle is radical compression. The entire assessment consists of exactly 14 total questions. Within that tight constraint, the survey actively measures 7 distinct affective variables. It gathers data on science, math, social studies, reading, writing, oral presentation, and the student's general attitude toward school. We are trading the deep precision of a 20-question survey for broad, actionable insight, relying on a minimum of just 2 items per target variable. To make those 2 items mathematically reliable, the survey employs a polarity pairing protocol. Notice item 5, I don't like to speak in front of the class. Every targeted variable requires an equal number of positive and negative statements. This negative statement is structurally balanced later in the test. Item 11 acts as its positive counterpart. I usually enjoy speaking in front of other students. This pairing dictates the scoring logic. Selecting true for me on a negative statement, like item 5, yields low points. Selecting that exact same option for the positive counterpart in item 11 yields high points. By aggressively compressing the length and carefully balancing the polarity of the items, the inventory maximizes the data yield across multiple subjects while bypassing student survey fatigue. The internal phrasing of these statements requires the same level of precise calibration. Notice the specific modifiers used to soften the statements, like in general in item 1, or the word usually in item 11. Extreme absolutes must be avoided. A sentence like, school is always the most enjoyable part of my day, is so polarized that almost every student will disagree with it, causing the data variance to collapse. These paired items must also be scattered randomly throughout the list. Grouping them by subject allows students to easily recognize the pattern and alter their responses. Even with perfect internal construction, the tool has one critical vulnerability: how it is physically collected in the classroom. The instructions explicitly state, do not write your name on the inventory, only make X marks. When you are finished, a student will collect your inventory. This targets a biological instinct known as the socially desirable response. When students believe a teacher can trace an answer back to them, they naturally provide the feedback they perceive the authority figure wants to hear. To engineer true physical anonymity, teachers must deploy blind collection boxes or designate student collectors who seal the responses before the teacher ever sees them. The most perfectly calibrated inventory is useless if the collection protocol fails to lower the student's defensive psychological filters. The multi-focus affective inventory serves as a highly calculated compromise, balancing strict psychometric validity against the harsh logistical constraints of a busy classroom. Once we bypass the social desirability bias and extract this data, what actually happens next? Consider a high school math class being monitored over the fall semester to gauge the students' ongoing interest in the material. This graph tracks student interest levels over time. In September, data shows 60% of students register positive interest, but October, it holds steady at 65%. Then in late November, the data reveals a sudden anomaly. Interest plummets to 25%. This drop acts as a glaring, real-time warning light. It indicates that whatever instructional module was introduced in November actively alienated the students. The educator's required response is immediate. They must review the specific curriculum used during that window and actively redesign the material to stop the affective bleed. Gathering this data is not an end in itself. We deploy these engineered inventories because the mere presence of post-instruction measurement ensures that teachers will adjust their planning to promote positive attitudes. The architecture of the assessment directly dictates the reality of the instruction.